Problem 5 says, without graphing, identify the x-intercept, y-intercept, and slope of each of the linear equations below. The y-intercept and the slope are trivial to identify because these equations have been given to you in slope-intercept form, which is y equals mx plus b. And so you can just identify m, you can identify b. That part's easy. The x-intercept takes a little bit more work. We'll look at that in just a second. Y equals mx plus b, so the slope for this first equation is positive 3. The y-intercept, which is b, is negative 2. Remember, it's y equals mx plus b, so if you're subtracting 2 from the variable term, you have to remember that subtracting 2 is the same as adding negative 2. So what are we adding to this variable term? We're adding negative 2, so b is negative 2. In this case, m is, the slope is 1/5, and b is positive 5. In this final equation, the slope is positive 5, and b, the y-intercept, is negative 3. Now, if we have, just remember, if we have x and y axes, this is y, this is x, and we have some line, the y-intercept, occurs when x equals 0, and that's why if you just imagine eliminating the variable term, this is why b, or the y-intercept, is just this constant term in slope-intercept form. But the x-intercept occurs when y equals 0. If I'm at this point where the line crosses the x-axis, I'm not up or down, so y is 0. So we solve for the x-intercept simply by rewriting the equation. For example, y equals 3x plus 3x minus 2. And if y equals 0, I just substitute 0 for y. 0 equals 3x minus 2, and then solve for x. If I want to solve for x, I want to isolate x. So I want to get rid of this constant term. I add 2 to both sides of the equation, property of equality, and additive inverse, because negative 2 plus 2 is 0, so I just have 2 equals 3x. Then I apply the multiplicative inverse, undoing this multiplication with division. 3 divided by 3 is 1. 1x is what I want, but I have to divide the other side of the equation by 3 because of property of equality. So 1x equals 2/3, or x equals 2/3. That's the x-intercept. Would occur at 2/3, 0. That would be the ordered pair for the x-intercept. We do the same thing here. Y equals 1/5 x plus 5. Set y equal to 0. Then solve for x. Subtract 5 from both sides of the equation. We get negative 5 equals 1/5 x. Multiply by 5. Maybe I'll show it on another line. 5 multiplied by 1/5 will be 1, so I'm multiplying by the reciprocal, which is the same as dividing by a fifth. But I have to multiply both sides of the equation by 5. So I get x equals 5 times negative 5 is negative 25. So the x-intercept for this equation is negative 25, 0. Lastly, y equals 5x minus 3. We set y equal to 0 to find the x-intercept. 0 equals 5x minus 3. I add 3 to both sides of the equation, and I get 3 is equal to 5x. Divide both sides of the equation by 5, and you get x equals 3/5. So this x-intercept would occur at 3/5, 0, that ordered pair. Okay, which, if any, of the graphs below are functions? So we can just do a vertical line test. We know that for every member of the domain there must be one and only one. Every member of the domain must be paired with one and only one member of the range. So if I pick any domain value, any x value, like with some sirens outside my window, like this one, since when x equals, I can't even read that, I think it's 2.5. When x equals 2.5, y can't equal this value and the opposite of this value. It just doesn't make sense. You need to have, for every input you need to have one and only one output. So you look at a vertical line test, and if that vertical line ever crosses more than one point on your graph, then you don't have a function. So this one is not a function. This one is not a function. I can intersect three points on this graph. C is definitely not a function, because if I make my vertical line right there, I intersect an infinite number of points. So A, B, and C are not functions. D is a function. Any point that I make my vertical line, I only intersect one point on this graph. So D is a function. E looks like a function until you get here. You see that it's going to intersect 2 points, so E is not a function. F is a function that you're going to become very familiar with later in your math classes. But anywhere I put my vertical line, I only intersect 1 point. So D and F are the only functions. The other 4 graphs failed the vertical line test.